plan and implement VMware fault tolerance. So you've got this VM, right? And this is one of those really particularly critical VMs, right? Yeah, it's a database that can never go down. It's an application server that, when it fails, it takes the entire company with it. These are the really important, these are the really highly critical, almost mission critical virtual machines in your environment. And up until this point, well, we've provided some high availability ways or high availability features that you can add that keep the availability of these types of virtual machines very high, but it doesn't keep them really, really high or perfectly high. You know, even the Exchange server can go down from time to time. I mean, people get irritated when the Exchange server goes down, but you know what? If it drops for 5 or 10 minutes or even an hour some days, it's not going to be a real earth-shatteringly big deal in some situations. But every so often, there pops up this workload, this virtual machine that requires an extra level of high availability, super high availability, if you will. And in those situations, that's when the technology known as VMware fault tolerance comes into play. Now, VMware fault tolerance is not a feature to enable lightly. There are some fairly significant requirements that you place upon a virtual machine that's going to be protected by VMware fault tolerance. And you lose a lot at the same time. You lose some configuration control, and you lose some of the nice fun features that you normally tag to virtual machines. So you're not going to implement FT just everywhere. You're also, with FT, unlike with high availability with HA, you actually have to have really 2 copies of the virtual machine up and running at all times. So turning this on, again, is going to reduce the amount of resources you have available for other environments. But if all these describe that one virtual machine that you really just can't ever go down, well, in those cases, VMware fault tolerance might be a solution that can help protect that virtual machine. So in this nugget, I want to show you some of the ways in which you can turn on fault tolerance, how you configure it, what are the initial configurations that are required, and then how you also just turn it on for a virtual machine. Before we get there, however, I really want you to understand, again, what the architecture is of fault tolerance and what you could pay, or what you're going to pay, and what you can lose if you just turn this thing on without really seriously considering the consequences. You've seen this picture before. This picture we looked at earlier, and it's got a 3-host environment there, and I've got 2 healthy servers. I've got a server that's just failed, and because that server has failed, well, these virtual machines now have failed over to the new host. This is the concept of VMware HA. And in an HA environment, as I mentioned, the loss of that host, when that host goes down, right, when you unplug the power cable off the back of that host, well, these virtual machines, they're going to die with the death of the host because they only exist in one place. You pull power from a host, and there's just no way that virtual machines can continue to process on that host. So while HA is a solution for providing higher availability for virtual machines, anytime you do lose a server, you're going to lose those VMs for just a very short period of time. How long does it take to boot a VM? I don't know, a couple of minutes. Less generally than what it takes to boot an equivalent host these days, because the boot process is so well streamlined. So while HA does indeed provide higher availability for certain VMs, you're not going to get complete availability in the case of a loss. So that's really what the use case that fault tolerance is designed to fix. So let's say I got this really important VM here. When I turn on fault tolerance for that really important VM, I actually create a pair for that VM, a mate for that VM, and essentially another VMDK file that exists down here on that piece of shared storage. So now I have 2 copies of this VM, one that's sitting on this server here, and one that's sitting on this server here. And every time something changes on this VM, it automatically changes over on this VM in lockstep. So bam, change happens, bam, it's replicated, bam, change happens, bam, it's replicated. And this creates essentially 2 copies of that workload, 2 copies in your shared storage, 2 copies on 2 different servers, such that if this server does indeed die, well, then the failed machine, or the surviving machine, can take over almost immediately from the failed server. No loss in service. a second of downtime as opposed to 4 minutes of downtime. So FT and its lockstep that it creates between two virtual machines reduces the amount of downtime whenever you have those exceptionally mission-critical virtual machines that you just have to protect. Now you can pair these two technologies together. You can pair HA and you can pair FT. As I said, you kind of lose some stuff. The FT virtual machine has some limitations that get placed on it, but HA and FT can operate together so that the other non-FT protected virtual machines just fail over to a new host just like they're supposed to, and your FT-enabled virtual machine that's operating in lockstep behaves the way it's supposed to because FT is indeed enabled on that machine. So this is really the architecture of fault tolerance. You really, again, want to take a look at, there's a document here on the vSphere 5 Documentation Center that outlines kind of the checklist of configurations and things that can and can't be turned on or must be turned on in certain circumstances for fault tolerance to work. There is a VMware site survey utility that you can download to better understand those configuration issues. But you'll notice here that there are a number of cluster requirements for fault tolerance. I'm going to step through these here in just a minute, but I want to make you aware of what these are from the cluster side, from the host side, and then also from the virtual machine side, so that you don't end up creating yourself a virtual machine that just is not fault tolerant capable. A couple of the big ones here is that you can't have supported devices attached to the virtual machine. The virtual machines must be thick provisioned. There can be no incompatible features on that machine. It must be on shared storage. And really important down here is only virtual machines with a single CPU. So one CPU only are supported by fault tolerance. If your virtual machine meets all of these requirements, as does your host and as does your cluster, well then turning it on isn't too terribly bad. I'm going to show you how to do it. Okay, now recall that this environment, the same vSphere environment we've been working with throughout this series, is running on top of VMware Workstation. So VMware Workstation is running ESXi, which is running the virtual machines, this whole nested virtualization situation. And when you do that, you kind of pay some prices too, because nested virtualization obfuscates some of the virtualization extensions. So I'm going to show you some of the things you would do in a production environment, and I'm also going to show you one little trick you'll have to do in your test environment if you're running a top workstation. The first thing you want to do is go up here to Administration and vCenter Server Settings. And you want to identify or ensure that under SSL settings that the vCenter server requires verified host SSL certificates. If you think about it, you got two VMs, right? And you got one VM that's sort of sending its updates to the other VM. Well, you want to assure that the other VM is authenticated before you start sending data off to somebody. So this kind of protects yourself against somebody stepping in the middle of these two VMs and saying, oh yeah, actually I'm really the VM you're looking for. This is enabled by default. You would have had to specifically disable that if you were to not see it this way. So the checkbox is there. The second step you have to do is you actually have to go through and enable a network interface, so a card, for fault tolerance. Now we talked about this before when we were working with those vCenter standard switches, right? When we had that vSwitch and I enabled vMotion on that virtual switch, and I showed you that you could do fault tolerance, but that little dialog box popped up that says, not a good idea. Well, I'm about to do that, and it's okay to do it in a testing situation, but in a real production situation, you would want to do it on an isolated network interface that's not shared with, for example, vMotion, because the amount of data that has to get moved from one machine to the other is fairly high, and it has to do it in near real time. So you don't want any kind of network congestion to impact the ability of that VM to move its updates to its secondary, or you're not really operating in lockstep anymore. So here's my distributed virtual switch that we created back in that previous nugget. I'm going to go here to Manage Virtual Adapters, and VMK0, which is that management virtual port that we created. And if I choose Edit here, here are all of the different services that I can bind to this port, one of which is fault tolerance logging. So let me turn this on, and this time I'm actually going to say OK, because I do want to turn this on, even though, again, a second reminder, don't do this in production. So that enables fault tolerance logging on this host's management network. Now, I've already done the same on ESX2 and ESX3, so you don't have to see it happen again, but you will have to turn this on for all the hosts that you want FT to operate on. So we've configured host certificate checking. We've got the networking set up across all three of these servers, two of which I did in the background. The last thing I have to do, and this is a special configuration that's required only because I'm doing this nested virtualization inside of VMware Workstation thing, and that is to go here under Edit Settings and make a special secret undocumented change to the advanced configuration options. What this change does, and there are 3 lines that you'll need to be aware of. What this change does is it essentially tells vCenter to not really be concerned that we're not terribly supported here, and just allow this to run so that we can test it. So here's our virtual machine properties dialog box. I'm going to click over here to options and to advanced general, and you'll see configuration parameters down here for advanced. This is where, as you will see, a number of very specific configuration parameters are identified. All of this is kind of quasi undocumented, so you'll find it on the internet, but it's really not something you're going to do again in production. There's these 3 items: replay.allow.bt only, replay.allow.ft, and replay.supported all need to be configured and all need to be set to true. You can avoid the replay.filename for now, but these 3 items essentially are what tells vCenter to, you know what, just sort of ignore the fact that this is just a test situation and allow me to do what I'm about to do with this virtual machine. So create those. Again, it's allow BT only, allow FT, and .supported. So once I've created those, and again, that's on the virtual machine that I'm about to add, or I'm about to make FT enabled. Once I do that, the next step in this process is to turn on fault tolerance. Now, I have already in the background, so before starting this, this videoing, I already went through and changed that VM from a thin provision VM to a thick provision VM. And one of the ways that you can do that fairly easily is if you want to go here to Inventory, Data Stores, and Data Store Clusters, and if you want to find the VM you're looking for or the data store you're looking for and browse it, in there, if you have the VM, you can actually right-click it and choose the Inflate item here. That will actually inflate a thin provision VM to become a thick provision VM. And I did that because the entire process takes about 15 minutes. I didn't figure you wanted to watch that countdown. But what that does is it makes the VM the entire size of what you've created the VM. It's now a thick provision VM, which is required, as I mentioned, for support by FT. So once I'm ready to FT enable this VM, and I've got its disk ready and I've got my networking ready, I can choose turn on fault tolerance. When I turn this on, there are a couple of things that are going to happen. The DRS automation level for this VM is going to change to disabled. Right? DRS is no longer going to actually move this thing around from a load balance perspective. I told you you're going to lose some things whenever you turn on FT. Also, the memory reservation of this VM is going to be changed to the memory size of the VM and maintain equal until fault tolerance is turned off. So essentially, you are now reserving the full quantity of the VM, the assigned memory to the VM, as a reservation. That pulls that. You're no longer able to overcommit your memory because the reservation is going to be set for this VM to as much as it needs. You're losing on the DRS side now, and you're also paying memory. The available memory you have is going to be reduced by whatever this amount is to support that because of this memory reservation. So this dialog box appears, are you sure you want to turn on FT? Once I do that, okay, once I turn on fault tolerance, you see how the second VM is being created. So in the background, it's actually turning on fault tolerance and creating and ultimately registering this secondary VM. 2 VMs, 2 VMDK files, right? Two disk files, 2 instances running on 2 different servers, both of which have this reservation. So you can see that, well, doing this is going to involve there's some thinking you're going to have to do before you decide whether or not this is important for your needs. So after a minute or so, fault tolerance is turned on for this VM. You will notice that at this point, it's very difficult to understand if fault tolerance is turned on, at least via this view. I can then go ahead and power on the VM and watch it begin operating. There we go. It's starting the fault-tolerant VM. It's migrating the active state. And here in just a minute or so, I'll actually have a protected virtual machine that's up and running. And we can actually, there we go, I do have HA protection on it. And now I do have a virtual machine that's operating inside of my cluster. If I click over here into our cluster and I look at virtual machines, I see VM1 here, and then VM1 secondary here as the secondary to this VM. VM1 is operating on ESX2, whereas VM1 secondary is operating on ESX1. So I now have these two VMs that are operating in lockstep, more or less. Now I say lockstep because they are not completely 100% in real time operating in lockstep. I mean, they may be a number of hundreds of milliseconds apart, or even as much as a second apart in a very bad day. But what this does is it illustrates how you can have VM1 and a VM1 secondary here that provide that whole fault tolerance existence between the two. As we make changes here to VM1, those changes are eventually going to propagate over to VM1, the secondary. And at any point in time if I want, I can go here to fault tolerance, and when these aren't grayed out, I can test the failover or migrate to the secondary. So what this does is it effectively presents a way so that I can create a secondary instance of a virtual machine so that if I should experience a problem and the first VM goes down, well, I have the ability to bring that second VM online whenever I need to. All of this, again, is something that you're going to want to implement only whenever you have taken a real good analysis of your business requirements to identify whether or not the things that you have to pay in order to get the fault tolerance are worth the benefits that you get out of receiving fault tolerance. So what we talked about in this nugget, we've really kind of come to an idea of what those requirements are, and I think I've helped you kind of understand what that use case is for enabling fault tolerance should you need to for those particularly mission critical workloads. We went through the process of configuring fault tolerance and how to enable and disable it on a virtual machine. Once you set up the specific settings that are required for that virtual machine, there's really not that much to look at. But once you do configure it, you can know that you do have a virtual machine that's fully protected. I hope this has been informative for you, and I'd like to thank you for viewing.